We are from the Department of Civil Engineering of National Engineering College. Today, our team is here to present the experiment on determination of index properties of the soil and the classification as per the IS code 1498. So, our teammates will explain the what are the experiments we are doing here. So, soil means it is one of the most important material in the construction because as it forms a foundation for all the material. Understanding its all the properties is essential for safe and the economical design. In order to identify the type of soil, we are going to do some important three experiments which are called sieve analysis, specific gravity test, and the relative density test. These three experiments were important by seeing the appearance of the soil that we have chosen. The main objectives of this experiment is to determine the index property such as grain size distribution, specific gravity, and the relative density, and then classify the soil using the IS classification code which have given for us. Then the soil samples which have taken for the experiment was collected from the Krishna Nahar, which is located in Palayam Kottai at Tirunelveli district.
Next, we performed the specific gravity test using picometer. First, we took a clean and dry picometer and measured its empty weight. Then we added now quantity of dry samples into a picometer and noted the weight. After that, we filled the picometer with water, removed all air bubbles by shaking gently, and recorded the combined weight of soil and water. Finally, we filled the picometer with only water and measured its weight. Using this observation, we calculated the specific gravity as the ratio of the weight of soil solids to the weight of an equal volume of water. From our calculations, the specific gravity of the soil is 2.785. From this test, we understood that the soil consists of dense mineral particles which typically of sandy soils, and the natural of the soil is compact material.
Sieve analysis and grain size parameters. In this experiment, we first conduct sieve analysis to determine the particle size distribution of the soil. A total of 500 grams of soil sample was taken and passed by a standard sieve series. From the result, we observed that the gravel content is 12%, coarse sand is 6%, medium sand is 52%, and fine sand is 40%. While fines are almost negligible. This clearly shows that the soil is predominantly sandy in nature. From the sieve analysis, we also plotted the grain size distribution curve, and from this graph, we obtained an important grain size parameter. The effective size D10 is 0.13 mm, D30 is 0.3 mm, and D60 is 0.5 mm. Using these values, we calculate the uniformity coefficient as 1.666 and the coefficient of curvature as 1.385. Since the uniformity coefficient is less than 6, the soil is considered poorly granulated soil. This means the particles are not well distributed across the different sizes. From this sieve analysis, we understand that the soil consists mainly of sand particles, has poor grained, and also water to pass the easily indicates high permeability but low cohesion. Thank you.
Next, to determine the relative density of the soil, next we perform the relative density test to determine the compactness of the soil. First, we determine the minimum density of the soil by allowing the dry soil to fall freely into a container without any compaction. We measured its weight and volume. Then we determine the maximum density of the soil in a container using vibration or damping, and again measure its weight and volume. Using these values, we calculate the relative density of the soil. From our calculation, the minimum density is 1.482 gram per cubic centimeter, and the maximum density is 1.697 gram per cubic centimeter. The relative density is found to be 73.5%. Since the relative density lies between 50% and 75%, the soil is considered to be in medium dense conditions. From the test, we understood that the soil has moderate strength and stability, and it can be made stronger by proper compaction.
Today I'm going to talk about the experiment that we done in soil mechanics. Totally we made three experiments. They are CO analysis, specific gravity test and relative density test. To conclude that we successfully conducted the experiments to determine the index properties of the given soil sample. First of all, from the CO analysis we found that the soil is predominantly in nature, which is poorly graded. From specific gravity test we found that the soil consists of dense mineral particles, which is a typical type of sands. And from the relative density test, we concluded that the soil has a dense medium condition, which have moderate stability and durability. Based on these results, the Indian Standards 1498 classified that the soil is poorly graded sand. Next, and this type of soil is suitable only for drainage and backfilling purposes, but this soil requires proper compaction or stabilization to use in structural applications. Finally, these experiments help us to understand the behavior and the engineering properties of the soil, which is essential for safe and effective constructions. Thank you.
Myself Sandhya. In front of soil, from the experimental results, we can infer that the soil sample is 98%. The uniformity coefficient value is 1.6, which is less than 6. So it indicating that the soil is poorly graded. Then the specific gravity of the soil is 2.785, which confirms the typical soil sample soil characteristics. Then the relative density is 73.5. It's showing that the soil is in medium dense conditions with moderate strength. As per IS 1498, the classifications of soil is SP, which means poorly graded sand. Of soil quality. To improve the quality of the soils, compaction can be done to increase and density and strength. Then adding fines like clay or silt, it increasing the gradations, and stabilizations for using cement or lime. It is used to increase the cohesion and the strength. Mixing different particle sizes can be converted into well graded soil, and geotextiles can be used to improve stability.